tell me if it is on.
It's on.
Okay.
No, it's not.
Is it like getting this part?
I do it all on Ooh. Yeah, 1, 3, 13, and 5.
Yeah.
But I'm not on it now, probably, right?
No.
Let's get there, though, because I'll probably start here and go over. Okay. All right, so if you missed yesterday, it was pretty easy because it was physics, and if you have physics, you'll be fine. Go through the homework answers. There's way more answers on there than you need because, like last year, I assigned way more problems, so there's only 4.
We still need to do the homework, right?
Yeah, just do the 4. Don't do all of them in the packet. And you'll be good. So today I was going to do derivatives of trig functions, which is fun. And then tomorrow we're going to do like a class assignment of just some practice and some challenge problems, and then Friday have a quiz. So I think this should be pretty good. And it'll put us on track to finishing where we're supposed to finish, although I know we're not thinking about finishing yet.
We have a quiz Monday and Friday. We have a lab report on Friday.
Taboo quiz. Tornado.
Taboo quiz.
Torpedo.
The only way I can do that is if we start including more sections on the test. You know what I mean? Like we can't just like. Yeah. Friday. Because then I could do that, and we could just do like more stuff. I thought, you know, what I thought now would be a good time is because if you're not keeping up, like if you're having trouble, it's good to know now. You know, maybe you were okay with the pre-cal stuff, but you're struggling now, so it's good to know before we get much further. Why am I holding a book? Don't look very serious in front of the camera. I guess so. Alright, derivatives of trig. What rhymes?
Derivatives of trig. It's like the least rhyming thing I've ever heard.
Good call.
Zach.
Especially.
That's creepy. But he did that last year. Zach.
Zach.
Zach. He didn't know about it.
No one does.
Okay, so there's not. I keep saying there's not that much you have to memorize, but this is definitely one of those things that you do. All the derivatives of the trig functions. So we already know what the derivative of sine and cosine is because we did it before, or I mentioned it, whatever, last week. So let's just prove one of them, just for fun. Just one. Okay, so derivative of sine is what? Cosine. So derivative of sine x is cosine x. But just for fun, let's go through and prove just this one. Once you prove the one, once you prove sine, cosine's easy. And then all the rest of them actually just come from quotient rule. So it doesn't get that difficult actually to prove the rest of them, since they're all kind of a derivative of sine and cosine themselves. So if y equals sine x, and I want to find the derivative of y, I want to find the limit as delta x approaches 0 of sine of x plus delta x minus sine of x over delta x. Make sure you actually like hear everything. I don't want you to get. I'll feel bad if you get distracted by it.
No, you won't.
Oh, you're right. I won't really. I'm just trying to look good for the camera. Make it seem like I'm caring. Okay. So definition of a derivative: f of x plus delta x minus f of x over delta x. So if you remember from pre-cal, you can't just like if I want to try to reduce this and plug in delta x going to 0. Realize if I plug in delta x going to 0, I'm going to get sine x minus sine x on top, 0, 0 on the bottom, 0 over 0, indeterminate form, something more. So do you remember from pre-cal that you can't distribute sine x? Do you remember what you do when you have sine of something
Sin
plus
X,
something?
cosine X.
It's
plus
that sum and difference formula things. So when it's sine, does it go sine, cosine, cosine, sine, or does it go sine, sine, cosine, cosine? Sine, cosine, cosine, sine. You don't have to have that memorized, and this is probably the only time it's useful. So all of those sum and difference identities in pre-cal is only useful like right now. Kind of. So we got sine x, cosine delta x. Does it stay plus or change to a minus?
Plus.
Stays a plus. Cosine x, sine delta x. All over delta x. And just like when we proved, was it product rule? We kind of made the fraction be what we wanted it to be so that things would work out. I don't have to insert anything tricky, but what I am going to do is I'm going to kind of rearrange a little bit. I'm going to take the sine x out of this and the sine x out of this and group those terms together so it'll look like this. I'm going to take the sine x of this and be left with cosine delta x minus 1 So I'm just grouping and factoring. So I'm grouping the first term and the third term, taking a sine x out, and then I have the middle term just hanging out at the end. And I'm going to group this the way I want it to be. I'm going to put the delta x under this one. Oops. And under that one. I want to make sure this makes sense. So I split it first into two fractions. I'm putting the delta x over this side and the delta x, under, and the delta x under this side. But I'm going to specifically put it with this one and specifically put it with this one. Because, do you remember those two special trig limits that we talked about in the end of pre-cal that led into the limits for this year? And you guys asked me about it, like, did you have to have it memorized for this class? Cosine delta x minus 1 over delta x, what does that go to? 0. Do you remember that one? That's the one we said wasn't important and you didn't really have to know. So this goes to 0. But over here, sine delta x over delta x, what does that go to? 1. So this goes to 1. Oops, that's supposed to be 1. So I have as my answer 0 plus cosine x times 1. So just cosine x. Yay, it works. The definition actually is true. If you went and did the cosine x one, you'd get the same thing. And when I did cosine of x plus delta x, I'd have to use the sum and difference identities. I'd have to group things up. Part of it's going to go to 0, part of it will go to, you maybe end up having subtraction there, so it goes to -1, and so I get a negative sine x. So, derivative of sine is cosine. Derivative of cosine is negative sine. And let's try to do one other. Let's do tangent. You know how tangent is sine over cosine? Like regular tangent is sine over cosine? Let's take the derivative using the quotient rule. So if our function is tangent, so our function is sine x over cosine x. Try it. See what you get for the derivative using the quotient rule with sine and cosine. Is it still in it? Is it still in it? What? I have to keep turning it. It's fine. All right, so try it. Hody hi, Heidi ho, blah blah.
Yes, sir.
Are you serious? Okay, so did you get here? Cosine squared plus sine squared. So what is cosine squared plus sine squared? 1. So we got 1 over cosine squared. And we actually don't leave it like that because that can be rewritten as secant squared. So the derivative of tangent is secant squared. And the others you can find the same way. I mean, cosecant is 1 over sine, so you can do quotient rule with that. Secant, 1 over cosine, you can do quotient rule, and this one you can do quotient rule with cosine over sine. So I'll just tell you what they are. The derivative of cosecant is, wait a second. Oh, negative cosecant cotangent. I didn't think about it, sorry. Negative cosecant x cotangent x. We better double check, wouldn't that be funny?
No.
Yeah, there we go. And the derivative of secant is secant x tangent x. And the derivative of cotangent is negative cosecant squared. And you will use them enough that you will have them memorized. I wouldn't be surprised if tomorrow there's like a 2-second pop quiz just on them. So that kind of defeats the purpose of the pop part, but yeah, memorize them. So if you use them a couple times, you'll get pretty good at it, and they're pretty easy. And you know, see the connection that if tangent derivative is secant squared, its partner is opposite sine and like the partner for secant. Do you know what I mean? Secant's like, I don't know, I think of secant's partner as cosecant, just like cosine and sine go together. For cosecant, it's kind of easy because cosecant's in it, cosecant cotangent, and then secant, secant tangent, I don't know. You just get good at memorizing them. It doesn't take that long. So again, I memorize them for tomorrow. So here's an example. Okay, so we're actually going to do this and look at it on our calculator. So find the equation of the tangent line to y equals tan x over x at x equals 2. So for finding the equation of the tangent line, we need 2 things. We need a slope and we need a point. The point's going to have an x value of 2, and I kind of forgot that it's going to be gross. I should have maybe made it trig-ish. Let's see if I can make this a little bit better. Let's go pi over 4. Then it's going to be gross the other way. Oh well, whatever. So at pi over 4, if I want to find the y value that goes with it, I have to plug pi over 4 into this function. So what is the tangent of pi over 4? 1 over pi over 4. So the y value that goes with it is 4 over 5. Everyone okay with that? So I get 1 over pi over 4, flip and multiply. And now let's get the slope. So to get the slope, I'm going to take the derivative. To take the derivative, what do you need to use? Quotient rule. So I'm going to go bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So I have x times secant squared x minus tan x over x squared. If I want to evaluate that at pi over 4. This would definitely be a calculator problem, so let's see what we get. Plug in pi over 4 for x. And what's the secant of pi over 4? What's sine and cosine of the pi over 4s? Root 2 over 2. So if secant is 1 over root 2 over 2, it's squared. Awesome. And then tangent of pi over 4 we said is 1. And x squared on the bottom is pi over 4 squared. Get a calculator. I know this sounds dumb, but use your calculator right now and see what you get for that. Some people like just have trouble actually getting the right decimal equivalent for that.
You can simplify 1 over root 2 over 2 to just root 2. And then
Well, if you square it too,
and you just get 2.
it's going to be much easier. So yeah, we got pi over 4 times
2.
2 minus 1 over pi over 4 squared. I think the least you can put into your calculator, the better. So is that definitely 2?
Yeah.
Yeah, okay. So I would still even go further and say this is pi over 2 minus 1 over pi squared over 16. I don't know. I don't know what's easiest to put in, but see what you get. Don't forget the top thing has to be in parentheses, or you got to at least press enter when you're finished with it. Did you get 0.925?
Yes.
Okay, 0.925. Okay, so find the equation of the line, tangent to that graph at that point. So we got the point, we had the x value, you plugged it into y to get the y, and now we have a slope. So we can set up the equation, y equals, y minus 4 over pi equals 0.925 times x minus pi over 4. Gross. Okay. So if it says support graphically, they actually want you to graph it. Now that doesn't mean you can't use your calculator, so let's use it to kind of get a look at this. If I want to support something graphically, what they want me to do is graph the original and graph the tangent line and show, or let that show that at the point pi over 4 on that graph, this line is tangent to it. So let's see, it should look pretty good. So in your y equals, put in tan x over x. And then in your other y equals, put this in, but obviously this has to be on the other side. I would leave the parentheses so I don't want to multiply that out. 0.925 times minus 4 plus. Okay, now before you press graph, go to your mode and make sure you're in radians. And also before you press graph, let's have an idea of like what we're looking at here as far as our window goes. I know everyone likes to go like zoom fit or whatever and see what you think you want or what the calculator wants you to see, but I want you to like take control of your calculator and you choose what you want to see. Well, if we want to see what this curve looks like with the tangent line at pi over 4, I want to make sure I'm really looking at the space around pi over 4. So maybe I would have a window of like negative pi over 2 to like pi. So I make sure I'm looking at a nice small window that's not too small, but small enough. And then as far as y values go, we know that I have to see what's happening at this y value of 4 over pi. Well, what number is 4 over pi pretty close to? 1-ish, because pi is 3.1, so 4 over 3 is like pretty close to 1. So whatever I'm looking at is going to be like about here somewhere. So let's look at like a bottom of, I don't know, -2 and a top of 3. When I say that, do you know where to put that in? Push window. Your x min is the leftmost point, so put that in as negative pi over 2. And your x max I'd put in as like pi. It doesn't have to be exactly this, but this is just a pretty decent idea. Y min like -2 and y max 3 should give us a pretty good picture. make you feel incomplete as a person.
Yes.
Seriously. So when I graphed it, I have like this thing scooping in, and I have this scooping out over here, and at pi over 4, wherever that turned out to be, I have my beautiful tangent line coming up and going past it. They didn't have a problem with their calculator. Or something not working right, they don't have it in right or whatever. It's beautiful. Frame it. Okay, sure? Alright, cool, let's do another one. Try this one. Find the second derivative of secant of x. How to find the second derivative of secant of x? So, first take the derivative of secant, get secant tan. Use product rule. First times the derivative of the second, plus second times derivative of the first. Put it together, and then the only thing that I would think, but I don't think it actually works. If you can ever clean stuff up, you know those Pythagorean triples from pre-cal? Sine squared plus cosine squared equals 1. We just used it for the derivative of sine. If I took a secant out, I'd have secant squared x plus tan squared x. I don't think that's anything though, right? Because it's like 1 plus secant squared is tan squared, I think. Or, yeah, I think that's right. But always just check. If you can replace something with a Pythagorean triple, do it. If you can't, don't. But this might be one, sometimes something like this will work out, and this would have been 1, and you could have gotten rid of it. In this case, it's not. So this is fine. This is also fine. Either way, leaving it is nothing's better or worse than the other. That's it. Questions? Okay, one more. Show that. Let's show that. Okay, show that secant x has a horizontal tangent line at x equals 0. What does it mean for something to have a horizontal tangent line? What's true about its derivative? When something has a horizontal tangent line, what's true about the derivative? The derivative is constant, but more than that, it's specifically 0. Because, for a tangent line, for something to have a horizontal tangent line, the slope at that spot is going to have to be 0. Okay, the slope is going to have to be 0. So the derivative is going to have to equal 0 for it to have a horizontal tangent line. So what they're basically asking is, show that this function's derivative is 0 when x equals 0. So let's take the derivative of this function. And the derivative of secant is secant x tan x. And let's figure out, when does it equal 0? Does it equal 0 when x equals 0? Well, secant tan is 1 over cosine times, whoops, sine over cosine. Well, what happens when x equals 0? Let's evaluate this at x equals 0. What is the cosine of 0? 1. What's the sine of 0? 0. Good, it does. Okay, so it's kind of showing that at 0, this thing has a horizontal tangent line because its derivative is 0 when x equals 0, so you're good. You also could have just done this. Do you remember what y equals secant x looks like? Remember how, I don't know how you guys did it in Gersbach's class, but when we did it, we just graphed cosine. So like cosine looks like this. And then the places where it hit the x-axis was an asymptote. And the places where it has its peaks was the secant graph. And then we could go back and erase cosine. So there was the graph of secant. Well, what's happening at x equals 0? It's got its low point, horizontal tangent line. And that would also happen over here, it would happen over here. Is that okay? All right, we're done.
Red button.